Thank you so much, everybody. It's really nice to be here. I was supposed to speak at Build Stuff a couple of years ago and had to have the wonderful David Whitney stand in for me, so it's nice to be here in person today. And yes, I'm going to be talking to you about building an editor that runs in your browser. That not only you can edit code in your browser, but you can actually run the code as well and see its output. But before we get started, I'd just like to ask you a question. I'm a developer advocate. I work at Dino. How many of you have actually heard of Dino before? OK, cool. OK, we're going on a learning journey today. How many of you are actually have used Dino before? I wonder because Dino actually runs Netlify's serverless functions, so I imagine a lot of you are actually using Dino without realizing it. But today we're going to be building a editor that runs in the browser, but why might we want to do that? Aside from it being a cool project, there's a few reasons why you might want to do this. If you work at a company that offers APIs, this is a really great tool to help developers with their onboarding experience. They can test out your APIs directly in the browser, see the output. And if you are running a low or no code solution, you might occasionally find that your developers actually want to write some code. So offering them the ability to do so and to actually run that code it's just a nice added extra onto your low, no code solution. And being able to actually see the output of their code and gain practical experience for your documentation is a really nice way of onboarding developers as well. So having an editor in your documentation can be really helpful. But running code that is going to be written by other people, you don't know what they're going to write. This can often present a problem. We can't just trust code that is written by anybody to run on our websites. Allowing third-party code execution is going to open us up to all kinds of security vulnerabilities, potentially malicious scripts. They could steal data. They could inject harmful code. They could compromise our users' security and privacy. So we need to prevent malicious code from wreaking havoc on our websites, basically. Not only that, but we're going to need to provide resources that are going to be able to run this code, things like CPU and memory, which could potentially impact the load times for our other users. And in order to build a system that's going to run third-party code, we're going to end up needing to provision a large amount of compute, probably install something like Kubernetes. Then we're going to need some sort of management API to make sure that only the correct shape of data gets deployed. We need to make sure the container instances are secure. We need to make sure that we don't run out of storage to run other people's code. I mean, this sounds like a job that's going to require an entire ops team. And the truth is that building managed runtimes, building a runtime that other people are going to be able to run code on is sort of $1 million worth of problem. And that's a pretty significant barrier to entry for a lot of people. So with all this in mind, how are we actually going to pull this off? To do so, we're going to need three things. We're going to need an app that's actually going to be the editor itself. We're going to need some sort of hosting to run this app on so that people can actually visit it. And finally, we're going to need an application platform that the users can run their code on, likely something like serverless functions. And without wanting to sound too much like this is a sales pitch, I work at Dino, and they happen to have all of these tools. So I will be using their tools, but you can, of course, use your favorite version, your favorite hosting, your favorite serverless functions. It is up to you, of course. So what is Dino? Dino is an open source JavaScript runtime for the modern web. It's built on web standards. We support a load of web APIs. It's built in Rust, which makes it super fast. It was built by the guy who originally built Node, but he built it 10 years after building Node, so he sort of took 10 years of learning, and this is his new project. includes a whole load of built-in tooling that you might find useful for your developer experience. So Dino comes with TypeScript out the box. You don't need TSC anymore. It's got linting, it's got formatting, it's got a test runner. So I personally think it's a really nice developer experience. I hope you will think the same after seeing this. And Dino works out the box with all of your modern web tools, so we're going to build our solution using things that I'm sure you've seen before, React, Vite, and TypeScript. We're going to host our app in Dino Deploy. Of course, you don't have to use Deploy, you can use your favorite, but the easiest and fastest way to deploy your code, your Dino code, is with Dino Deploy. It's just a web hosting platform very similar to Heroku. And apps are powered by the Dino runtime when they're on deploy, so they're super fast. You can deploy with the GitHub action. It's all the stuff that you're already used to. And the final piece of our puzzle that I mentioned is serverless functions. So we're going to need a capability to not only run code, but run it in a hosted sandbox, which is going to keep the code nice and secure. And Dino offers sub-hosting, which is exactly that. It's serverless functions that are run on an entirely sandbox runtime so that you don't have to worry about things like keeping the code that you're running secure. That is already done for you. Sub-hosting supports JavaScript and TypeScript. It's super fast, it's low latency. It's got a very fast cold start time, which is exactly what we need to run code that people are typing into a browser. So with all of this in mind, let's get started and build something. So setting up Dino is super easy. First, you need to install it. You can do so with curl or chocolatey or anything that you're used to. If you've used Dino in the past, a lot has changed. It's a lot more familiar than you think. We support all of the Node APIs. If you're coming from Node and you're used to writing in Node, your Node project will just work with Dino. Dino's got a VS Code extension, which makes it super easy to use in VS Code, which does all your syntax highlighting and all of that. And so we're going to set ourselves up with a basic project. So you can do that with the Dino init command, which will set you up with just a very basic project directory with a TypeScript file, a test file, and a config file. And if you're coming from Node, you will find this very familiar. The config file looks just like your package.json, and we're just going to be writing TypeScript. Next up, we're going to need to install some dependencies. Again, if you're coming from Node, this should look very familiar to you. So as I mentioned, we're going to be using React and Vite. So I'm going to install our React and Vite dependencies. We're also going to be needing some env variables, so I've got .env in there, and we're going to be styling our editor with Prism. So I've got Prism in there. And then we are going to edit our config file. So if you're used to your package.json, you're used to having your scripts in there. In your dino.json, we're going to have a tasks field where we're going to add in a new task, which is going to run our Vite server so we can start some local development. And just looking at this here, you will see, can I get my cursor? Yeah, you can see a -a in here. What this is doing is it's allowing permissions. So by default, Dino doesn't allow your code to have access to sensitive APIs. So when you're running a Node task, when you've got a whole load of dependencies, you don't know what has access to what. And Dino, by default, doesn't allow access to network, doesn't allow access to file read and write, to environment variables, and you need to specifically allow them, and it just keeps your code a little bit more secure. -a is just saying, allow access to everything. You know, we're in our development environment, we're pretty certain that the modules that we're using, we know what they do, so -a just says, give permissions to everything. Oh, that hasn't rendered very nicely. So this is what our Dino JSON will look like now on the right here. So you can see we've got 2 tasks, and we've got all our imports in there. So we're going to set up the app now, and we're going to need to have 2 parts of this app. We've got a front end, which is going to be the editor itself, and then we've got the back end, which is actually going to do the server-side code. So it's going to actually talk to the Dino subhosting API, run this code, return the result back to us so that we can display it in the browser. So we're going to set up 2 folders in our project directory, a client folder and a server folder. There we go. That looks a bit nicer. We're going to do a bit of config for Vite. Because we're using Vite for our local dev, we just need to make sure that it's looking for the correct client directory, and that it understands that it's using React, and that we're correctly configuring JSX. So this is what your Vite config is going to look like if you're setting up just a basic Vite app. Now let's scaffold out the server side of our app. So our directory structure is going to look like this. These are the files that you're going to need to make, the files and folders. So we've got, as I mentioned earlier, we've got our client directory, we've got our server directory. The client directory is where we're going to write our React app. You can see here we've got a source folder that's got a TSX, an app.tsx and a main TSX. This is all stuff that you should be very familiar with. This is just a basic React app setup. And then in server, we're going to set up a basic HTTP server. We're going to set up some routes, and we're going to when we build the React app, we're going to serve it from that server when we deploy it. And excuse my basic UI design, but this is what we're going to build. So it's going to have a text area on the left-hand side where our developers can type in code. It's going to have a button that says Run My Code, and then there's going to be an iFrame underneath that button that displays the output of what has been run. So let's talk about the logic that we're going to need in order to actually power this. The user's going to type their code into the React UI, and then they're going to click the Run My Code button. And our server-side app is going to basically fork that code, take a copy of it, and send it off to the subhosting API. The subhosting API is going to create a new serverless function, run the code in that sandboxed environment, and return the URL of a deployment. We can then show the contents of that URL in an iFrame in the UI. So let's build out that UI. For the purposes of this demo, I'm going to throw together a pretty lo-fi React app. So we're using React Router. We're going to make 2 logical pages in our app. We're going to have a view page and an edit page. Now, the reason for doing this is we don't want to spam our subhosting account every time somebody lands on the view page. So we're giving them a little extra step before they start talking to the subhosting API. So they'll land on the view page first, just see some basic example code. Then they can press edit. They'll be able to start editing, and we can start talking to the subhosting API. Our app is super simple. Each page itself, the edit page, the view page are both just a component. And let's take a quick look at the view code component. So I folded away the functions here. We'll take a look at those in a bit. But for now, we can see that what we're doing is we're getting this block of sample code that we're going to set up. We're displaying it in a pre-element down here. So this is just an HTML element that's going to hold our code. And then we have a button that when they press is going to fork the code and set up a new subhosting function. Now we're getting a little bit more complicated, and the font size is getting smaller. I hope you can all see this. This is our edit code component. So on this page, we've got a text area instead of that pre, and this is going to allow our users to actually type. We're going to put the code from that example into the text area to start, just so they're not presented with the blank page, but they'll be able to delete it and start editing. Then we have a button to run the code. And finally, we have the iFrame, which is going to display the running instance of the code. The iFrame is in a component called Deployment Viewer. It's a very simple component. It's basically just an iFrame. So I'm not going to bother to show you that component, but just assume that that's what it is. So let's look at the logic of what this component is going to do. We'll first add in a few state variables, which are going to make the UI reactive. And then we're going to set up the text area with the example code. Then we're going to add the deploy changes function, so that when the user clicks on the run button to deploy their changes, we'll call our server-side API with whatever has been typed into that text area. And this API is going to then interact with the Dino subhosting API. As I mentioned, take a copy of this code, host it in a new function, and then each hosted function gets its own URL, which is returned to us, and we can display it in the iFrame. Let's take a look at the API client that we imported back into our two pages. So we've got our edit page and our view page. They're both importing this API client. And this is what is responsible for doing our fetch requests. So there's a few different functions in here. There's one which is going to load the sample code. There's another which is going to be used to actually deploy a project. And that's responsible for both creating and updating the code sandbox. And then finally, we have the wait for deployment function, which is going to allow us to poll to see if our running function is ready. And we do this by calling the getDeployment API. But we haven't actually set up any of these APIs yet. So let's go now from our client folder into our server folder and set up some of these APIs. So when we first deploy this application, we're going to need to have something to host it. At the moment, we're hosting it locally with Feet, but we're going to need to create some sort of HTTP server to do that when we actually deploy. So we're going to create a Dino server-side app that we can deploy to host. So this is the entry point to that app. This is just main TS. And this file uses some middleware called Oak, which is going to provide our URL routing. And here you can see an example. This is kind of interesting. So we are directly importing this into the file here. So this is our Oak functions that we're going to need to use. There's a few different ways of importing dependencies in Dino. You can import them directly with the URL. You can import them directly with either JSR or NPM. And here you can see an example of us importing it directly from JSR instead of adding it to our dependencies in our config. And this is going to be super useful later when we are actually running code that users can type in, because they can actually start importing packages and run them in the serverless functions directly, which is super cool. So all we're doing here is we are initializing a very simple HTTP router. We're using it to serve our static files from our client dist and our client public, which is just inside the current working directory. Then what we're going to do is we're going to update the server-side API with functions which are going to implement the features that we just spoke about in the editor. So we've got our get sample code, we've got our deploy project, and we've got our get deployment. And you'll notice that each route is mapped using its verb and its path, followed by a function which is going to handle any matching requests. So let's now build out each of these functions, the get sample code, the deploy project, and the get deployment. So the get sample code is a good first example of what an Oak route handler looks like. So if we take a look at this file here, all the handler does is it loads a file from the file system using Dino's file system APIs, and it returns the body of that file in a JSON object. And here you can see how Oak works. You just need to assign the response body on the context object provided as a function argument. Very simple. Let's look at a slightly more interesting example now. So our deploy projects. This is going to do most of the work for creating our new subhosting instances. So when this API is called, first we're going to check to see if an ID has been passed as a parameter. If it has, that means we have an existing project, so our user has already typed in some code and hit run this code. If they haven't, we're going to create a new deployment for them. Once we've got a valid project ID, we'll then work out what content we need to update the project with. So if our API receives some code as a post body, we'll use that, assuming that the user has posted this code. Otherwise, we're going to default to our sample code, which we provided for them in the editor. Once we've got our project ID and our code, we create this files map. And this is perhaps premature optimization for this particular example. But what this is doing is it's pretending to be a file system, where we give each file being uploaded a file name and some text contents. At the moment, we're only ever going to have main.ts, but you could potentially build out this example to run entire projects. So then we ask our client to deploy our project, passing this files map, and then we return the project, the deployment, and the subsequently deployed URL back to our UI to load into the iFrame. And in order to keep our HTTP API handlers simple, we've created this Dino subhosting clients file. This is just an abridged example that I'm showing, but what it's doing is it's sending requests to Dino's subhosting using fetch, which is built into Dino. And each of the functions of this subhosting client represent a Dino API call. So we're either creating a new project or we're getting a project that already exists and updating it. And if we validate our status codes and add some nice TypeScript definitions to the response objects, then we return them. The final thing to do is to update the Dino JSON to tell it about this new HTTP server that we've just made. So we're going to add a build task in here. So you can see we've got a Vite build, which is going to build our local app. And then we've got server start, which is going to run the server that we've just built. And now we can run our app locally with Vite. And in production, we can use this server that we just built. And if we do run it, it looks like this. Stunning. As you can tell, graphic design is my passion. So we can definitely do better than this. We can apply some styles to it to make the UI look a little bit better. I'm not going to go over the CSS with you, but all of the code in this talk is available on GitHub, and I will share it at the end. But here you can see we've got our text area, we've got our button, and we've got our iFrame. And I've also put the URL of the iFrame onto the page, just so that the user can see where their deployment is. If I apply a little bit of styles, it looks like this, which is better. But we still have a text area here, which has got plain white text. And ideally, we'd like some syntax highlighted code. That's what makes an editor an editor. And luckily, there are plenty of packages out there that are going to apply syntax highlighting for you, because otherwise that would be a monumental task for us to try and do right now. Read through every single word that is typed in, work out what color it needs to be. So I'm going to use PrismJS and specifically their TypeScript and JavaScript components to apply the styles to my editor. They've got a really nice, easy-to-use NPM package that we can just import, and that's going to wrap all the text in spans and then apply CSS styles to those spans. But we're going to hit a problem here, because if we go back, this is a text area. And at the moment, you can't put spans into a text area. So this presents a problem. But luckily, somebody has actually hit this problem before me and worked out an amazing hack. So what we could do is we could swap out the text area for a content editable element. But the problem that happens there is when Prism applies the spans and wraps all the text in HTML elements, the DOM manipulation causes the cursor to be moved to the start of the code. And that's a horrible experience for your editor who's started typing and then suddenly the cursor's moved back to the start. So we don't want to swap to a content editable element, but as I mentioned, text areas can only contain plain text. They can't contain HTML. So the solution discovered by Oliver Gear is this. So we add a code block to the page underneath our text area. We style the text area to be transparent and make the text typed into the text area transparent as well. We make both the text area and the code the same width, the same height, the same font size, and the same line height. And then we position them both absolutely with the text area on top of the code block. Then when the user types into the text area, the cursor is going to move as they type, but the text that they're typing will be invisible and will actually be displayed in the code block underneath. Because what we're going to do is on input of the text area, we take a copy of the value of that input, which is the code that has been typed. We apply PrismJS to that code, and then we put that updated code into the code block, which is hidden behind the text area. So it looks like you're typing syntax highlighted code, but you're not, which is just, it's such a super clever hack, and I was so happy when I found this. So amazing, that is our finished app. The only thing left to do is to deploy it, and then I will show you what our syntax highlighting looks like. There we go. So I'm using Dino deploy to deploy this, as I mentioned. Dino deploy is an online tool. It works like any of your other GitOps-based hosting. You've likely seen similar before. You register your Git repo. You can add in your build step, your install step, all the rest of it. What it's going to do is it's going to create a GitHub action in your repository. And then it's every time you make a change in your code, it will deploy, and you will be given a URL, and you'll have your project online. The important thing to make sure that you do right here is you run the Dino build command. So we set up that build command earlier in our Dino JSON, so we just need to make sure that we tell deploy about it. And fingers crossed to the demo gods, here is one I deployed earlier. Let's see if we can get this working. So here is my beautiful editor with, as you will see, some syntax highlighting. And I can update the code in here, so I can say, hello, build stuff, if I could type. And I can run this code. And we trust that the internet in here is not going to be too slow. Oh, yes, it's updated. There we go. We can see hello build stuff has shown here in our iFrame. And we can do even more complicated things with this, because the cool thing about subhosting is that all your packages, the things that we saw, that direct import that we saw, just magically work using Dino and using JSR. So we can directly import packages and actually run them in subhosting. So if I, instead of this very basic little server example here, if I use the Oak framework, I could do a much more complicated server with routing and all sorts of things. So let's take an example here. I'm not going to type this out. I'm going to copy pasta. So yeah, let's take a look at this example here. So you can see I'm importing packages, and I'm just going to give us a JSON response. If we run this code, there we go. We can see the response there, foo bar. So the subhosting has found those packages, installed them, run them, and we could potentially create a whole load of extra routes with this. We could do all sorts of exciting things. The one thing to note about this demo is that you do have to open an HTTP server for it to work, because the health checks on subhosting depend on you actually subhosting some code. But if you wanted to, you could abstract that all away, wrap your code in the HTTP server so that the user doesn't even see it. Yeah, so that is our editor. Just to show you the hack that is happening. So I can make the text area smaller and absolutely ruin our editor there. But I think, honestly, for a half-an-hour demo, that is definitely a good enough hack. As I mentioned, all of the code that I've spoken about is all on GitHub. So if you would like to make your own browser editor, you absolutely can. The code is on GitHub at, this is Joe Frank /Dino code sandbox. I've also shared the slides, so if you want the step through, you can absolutely take that. All of my slides have full speaker notes in them as well, so it'll actually walk you through building the app. Dino has just released Dino 2. So all of your Node projects will absolutely run with Dino. If you've not tried Dino yet, I recommend giving it a try. I hope that you will love it. We have a whole load of interesting APIs that I think make your developer experience much more pleasant. In fact, you saw one briefly there, the dino.serve API that set you up a little HTTP server in one line of code. There's a whole load of fun things to try out, so I highly recommend you do so. I have got some cute stickers down the front if you would like some stickers. But yeah, that has been a super fast intro to building a code editor that runs in the browser. Thank you so much for listening.